Welcome back. A virtual private cloud, or VPC, is a virtual network that provides the networking layer for many AWS services, not the least of which is EC2. A VPC can contain not just EC2 instances, but relational database service, or RDS instances as well. In fact, RDS instances are really just EC2 instances managed by AWS. Now, AWS manages the underlying VPC network infrastructure, and there is a lot of redundancy built in, so you don't need to worry about a router going down or a mouse or a rat chewing through a network cable or a switch failing. Where you do have to start thinking about redundancy is at the subnet level. A VPC contains one or more subnets, and a subnet exists in one and only one availability zone. An EC2 or RDS instance exists in one and only one subnet. You cannot have an instance in multiple availability zones. An instance is tied to one zone, and once you create it, you cannot move it to another zone. Now, I keep emphasizing one and only here to emphasize the fact that instances inherently lack redundancy. This is why an individual EC2 instance has an availability of only 90%. Even though the redundant network infrastructure underpinning a VPC is reliable, an instance can exist in one and only one availability zone. If that zone fails, the instance fails. When it comes to availability within your VPC, your number one concern is to distribute your EC2 and RDS instances across different availability zones. How do you do that? Well, I'll tell you. Take a look at this diagram. In this VPC, we have 4 subnets total. Public subnet A and private subnet A are in availability zone A. These two subnets share the same fate, meaning if zone A fails, both of these subnets will fail. This is why we also want to have subnets in a different zone. Zone B. It's unlikely that zone A and zone B will fail at the same time. Again, an availability zone is basically a data center. It exists in a particular physical location. Separate zones are geographically separated. All right, that's how you create redundancy within a VPC network. The next consideration is ensuring you have reliable connectivity to your VPC. A VPC has a region-wide scope. That is, it can exist only in a single AWS region. By default, a VPC is isolated from everything outside the VPC. There are 3 ways to connect to your VPC resources. Number 1, directly over the internet. Number 2, over a virtual private network or VPN connection that traverses the internet. Or 3, over a direct connect link, which is a private dedicated link to AWS. If you want to connect a VPC to another VPC or to an on-premises network like an office or a data center, you can use the AWS Transit Gateway service. A transit gateway can connect multiple VPCs together, and it can even establish virtual private network or VPN connections to external networks. I think of the transit gateway as the glue that holds your VPCs and your on-premises networks together. It is a highly available, elastic resource, so you don't have to create multiple transit gateways for redundancy or worry about performance. You create one per region, attach it to the networks you want to connect, and AWS ensures that it's almost always available. We're going to create a transit gateway a bit later on in the course. All right, in this lesson, we're going to cover allocating and assigning elastic IP addresses, which are persistent public IP addresses. We'll then dive into creating a VPC, creating public and private subnets, and launching instances into those public and private subnets. Finally, we'll discuss options for connecting your VPCs to your on-premises networks using Direct Connect and transit gateways. It's a lot to cover. Are you ready? Let's get started.